to start this session. So, first of all, a very good afternoon to all the distinguished speakers, attendees, and our friends from the industry. It's a real privilege to be a part of this session, which focuses on utilization of digital project management tools for project management. I think we all have executed projects in the past and can appreciate the importance what digital project management can bring in terms of the overall efficiency of project monitoring and control, especially in terms of early warning signals, having an integrated progress review, coordination across stakeholders. So I hope this is going to be a very well-heard session and we'll get a lot of new insights. So with this, I hand it over to my co-chair, Mr. Singh, for a couple of lines.
Thank you, Vaibhav. Good afternoon, everybody. I think as you know, for the topic of today, the digital tools have really revolutionized the project management, the communication, the collaboration, or the project progress tracking. So all has been made efficient with the use of the digital tools. And today we'll have a very eminent panel, and I hope you all have had a good lunch, and today you'll have a good food for thought also. So I'll just, it's already displayed, but we have 5 speakers today. First is Errol Pinto. He is a Senior Policy and Commercial Lead, Global CCS Institute. And then my colleague from EIL, Avishek Prakash, Senior Managers, Engineers India Limited. Then Parth Protim is Chief Engineer Production, Eastern Oil India. Then Tarun Kumar Mishra. I think Mr. Tarun has not turned up as yet. And he's a Chief Strategy Officer, Detect Technology. And then we have Vivek Jaiswal. He's Executive Vice President, Renew Energy. And I am RK Singh, Executive Construction in EIL. So with this, I think we can begin the session. I'll call upon Mr. Errol Pinto for his presentation. Mr. Errol Pinto, please.
My name is Errol Pinto. I'm a Senior Policy and Commercial Lead at the Global CCS Institute, and I'm very pleased to be here this afternoon at India Energy Week, and look forward to this talk and to connecting with any of you later. So a bit about the Global CCS Institute for those that haven't had the chance to be familiar with the Institute. We are an international non-profit climate change think tank. We're headquartered in Melbourne in Australia, but we also have offices all over the world, in Washington, D.C., in Houston, where I'm based, in London, Brussels, to name a few cities. We are a member-based organization, so we have over 200 members that comprise governments, corporations, technology companies, research organizations, and several non-governmental organizations as well. We are singularly focused on CCS, and we do fact-based CCS advocacy. We facilitate that with catalytic thought leadership and authoritative knowledge sharing. So the outline of today's presentation, I was slotted into this session, into session number 19, but my talk was going to be on CCS, on carbon capture and storage. So the outline of today's talk was going to be some context setting on the need for CCS. Why do we need to have carbon capture and storage in the first place? An overview of policy developments internationally. And I also wanted to talk about what developments we've had here in India and how they could potentially apply to CCS. Monetary incentives and the carbon markets are crucial to making CCS projects work, and we'll go over that on a couple of slides. And then we'll finally end with some key takeaways. So why do we need to have carbon capture and storage? Why is CCS important? So here's an informative graphic that shows CO2 emissions from energy combustion and industrial processes going all the way back to early 1900s. Actually, the graph starts from 1900 and it ends at about 2022, and there's a projection. What this is meant to illustrate is that it took 65 years for us to emit about 10 gigatons. But then that same volume, 10 gigatons, we emitted that in 25 years, from 1960 to about 1985. And then the next 10 gigatons took only 20 years. Right now, we're sitting at around 40 gigatons of CO2. And what we need to do is we need to get this CO2 out of the atmosphere, and there's a way to do that. CCS can help facilitate that process. As part of the work that we do, every year we put out an informative global status of CCS report where we cover CCS project development globally, and there's an informative write-up and graphics that showcase how the project pipeline has evolved over the years. So what you can see here is that over the course of a decade plus, the number of operational projects has actually not increased that much. That's the dark blue. But you'll notice that projects in early development and in the development phase started to shoot up in about the 2021, 2022 timeframe. And I'll get to why that happened. But what we want to take away from this slide is that there's about 49, close to 50 metric tons per annum of CO2 carbon capture capacity in operation today in about 40 to 41 CCS facilities globally. And there are close to 200 new CCS facilities that have been added to the project pipeline since our 2022 report. We release our reports towards the end of the year. And this slide will give us some insight into why we've seen that big uptick from 2021 into 2022 and into 2023. The main driver is policy development. And this is a selective overview of policy developments. And what I'm covering on this slide is how crucial policy developments in the United States have been to the growth of CCS projects. So what you'll see on the bottom part of that slide is the bipartisan infrastructure law, which was the law that was passed in 2021, was crucial because it allocated funds directly for research hubs, clean energy demonstrations, and carbon utilization programs, carbon capture demonstration programs. And you'll see the funding that this law was able to allocate. Congress allocated this funding. That was in 2021. In 2022, Congress rehashed what's called the 45Q tax credit. It's a section of the US tax code that allocates tax credits for CCS projects. They overhauled that portion of the law and they increased the tax credit from about $50 per ton of CO2 to about $85 per ton of CO2 for geological storage of CO2. So this broadly increased the pipeline of projects that were now able to make it to the investment stage. And the law also broadened the ability to transfer these credits. Previously, the credits could not be transferred. And there were other features that were built into the law that made it possible for the credits to actually work its way through the investment system. So clearly, policy development had a big part to play in projects moving forward in the US. But the US isn't alone. we can see from policy developments in other countries, especially the United Kingdom, that it's moved projects forward there too. So the the UK has used what's kind of like a three-pronged approach. They have an industrial decarbonization strategy that sits at the top. It's a broad plan that enables the UK to set out a pathway for decarbonization over the course of a decade or a decade plus. But then they follow that up with a CCS infrastructure fund that directly allocates funds to support CCS investments. And that's crucial to move CCS projects forward. And what's good about that fund is that it supports transport and storage infrastructure as well, which tends to be overlooked. And finally, the regional cluster approach in the UK that was set up helps allocate funding to the right types of industrial clusters. And there are two big industrial clusters right now in the UK. This hub and cluster approach is an approach that has worked well in many parts of the world. It's even being looked at very carefully in the United States as well. So I wanted to make sure that I also covered what's going on in India and what's the context of policy development in India. Long story short, India doesn't have, at least at this time, it doesn't have a broad encompassing CCS policy framework, but what it does have are certain components and certain events that have happened that could prove to be a catalyst for CCS projects moving forward. A big one is the amendment to the Energy Conservation Bill in 2022 that authorized India's central government to set up a domestic carbon credit trading scheme. This is meant to be for the domestic market, but India has a huge domestic market that could potentially benefit from this. There's also the G20 presidency, where the government acknowledged in primers that CCUS can contribute to India achieving its climate goals, which are pretty good. Then there's the CCUS report that Niti Aayog released towards the end of 2022, which is the first comprehensive CCUS policy framework from the Indian government. And it's a great report for those that haven't read it. For those that have, I'm sure they'll agree. It's an internal recommendation from the government to itself on what the government should do, really. And it's a nice global overview of the CCS landscape. And there's also recommendations in there for what the government could do to set up tax and cash credits similar to what other countries have done. And then finally, there are supporting institutions in India. There's the National Center for Excellence in CCU in Mumbai that was set up that was inaugurated in February of last year. And there's also another one at the Jawaharlal Nehru Center for Advanced Scientific Research in Bangalore. So these four components kind of give us some insight into where CCS policy could potentially be heading. And overall, it looks good. I don't have much time left. My clock is ticking down, but I wanted to make sure that I cover monetary incentives and carbon markets. These are crucial for CCS to work. This is a busy slide, but I'll summarize. Carbon pricing is really important. A carbon price or a carbon tax is really influential in setting a price, because the lack of one can slow down project development, because projects can move to jurisdictions that don't have pricing. Market mechanisms are really important as well. So emissions trading schemes, also known as cap and trade systems, are active in many parts of the world, but very few cover CCS at this time. The mechanics of how they operate can differ, but generally allowances are either allocated or auctioned. CCS business models, there are quite a few that are developing, but they kind of fall into four broad categories. There's the full value chain model, which covers the capture on surface, the transportation, and storage in subsurface formations. There's also the networks and hubs model. There's capture as a service, and there's transport and storage as a service. Depending on which industries are involved, their expertise would drive them towards one of these four business models. And finally, CCS cost structure. It's a sum of the costs along the value chain, capture at the source, compression, transportation, usually through pipelines, and then finally injection through a well into suitable geology. And there's monitoring and verification. There are different methods and standards that have been developed worldwide for that. So key takeaways, I've only got a minute left. There's a big need for a comprehensive CCS policy framework. It's important, it needs to be there. The framework should contain certain key elements, like a monetary value in CO2, access to low cost capital, and the prioritization of CCS hubs. The framework should also consider strategic objectives in the short, medium, and long term. And finally, focus on CCS hubs because they can help with economies of scale, synergies of co-location, and overall social and economic benefits. And CCS hubs are also key for CO2 management for emissions-intensive sectors, which is what we're talking about in this week at India Energy Week. Thank you, and I appreciate your time.
Thank you, Errol. I think you have completed in time. Just to remind the speakers, it is 14 minutes each, and I think Mr. Errol has completed in 14 minutes. Thank you, Errol. Now I'll call upon Mr. Avishek Prakash, Senior Manager, Engineers India Limited, speak on leveraging data analytics and AI ML for improved project risk management of capital projects in engineer sector of India. Mr. Avishek.
Good afternoon, everyone. Hope I'm audible. First of all, thank you very much for giving this opportunity to speak on this privileged platform. Three words said by the Honorable Minister of Petroleum and Natural Gas caught my fancy: accessibility, affordability, and sustainability. The Errol just before me talked about the last aspect, sustainability. But the question is, why do we do projects? So this is an extract from the National Family Health Survey conducted in 2021. And what is surprising to note is that households using clean cooking fuel is 58%. This means that 120 million households still do not have access to clean cooking fuel. This means that women of our country have to walk miles to carry firewood. Similarly, there's an issue about clean drinking water. There's an issue about education. There are issues about highways and other infrastructure. We are doing projects to solve these problems. We are doing projects to bring smiles on the faces of 1.4 billion world citizens. It is for this reason that Government of India last year budgeted a spend of 10 lakh crores. In the just presented budget by the Honorable Finance Minister, the budget for the current year is 11.1 lakh crores. That's approximately 19% increase year on year. All these projects, all this money is going to go into projects. Now we all know that projects are very, very complex. They have multiple stakeholders, long time, high capex, and so on and so forth. And therefore, we have got multiple international standards to manage these. So we have got the famous PMI Institute. We have got ACE, which is the TCM framework. We have ISO standards. We also have industry bodies like CII. We have got, think tanks like Gatton Institute. What these standards broadly speak about is all the different aspects of project management, be it scope management, change management, project planning, risk management, so on and so forth. All these standards talk about it the same. But what is surprising is that in spite of all these standards, 46% of our projects are delayed. This is an extract from the flash report by Ministry of Statistics, the November report. This means that almost every alternate project is going to get delayed. 22% of our projects suffer cost overrun. What this implies that if I'm spending 1.1 lakh crores, 11.1 lakh crores I've budgeted in the current year, there's going to be a 22% of those projects are going to, go over budget. Now the question is that, is this situation specific to India? The answer is no. So there's a study by ACE International specifically pertaining to the historical trends in the petroleum sector. So there was a cost overrun of 34% in the, that is the average cost overrun in all the petroleum sector projects. For the current year, or the November report, 26% is the cost overrun. Okay. So we are not, there's been a lot of, so there's not been a significant improvement in the, cost overrun status over the last, say, 10 odd years. Looking into this aspect, there was a study conducted by the Project Management Institute and KPMG, and the reasons of cost overrun were they tried to ascertain the reasons for cost overrun. Okay, and what they found out is that embedding risk culture or risk management can lead to 12% savings in cost overrun. If you are looking at the time overrun aspect, then embedding risk culture can help save 5% of your time overrun, which brings us to the topic of my presentation, that is risk management. What is risk management? There are a number of definitions, but basically it is the spare tire of your car. If you have a puncture, then you can replace the tire and reach your destination. So ISO defines it as the effect of uncertainty on the project objectives. PMI defines it as the uncertain event or condition that, if it occurs, has a positive or negative effect on the project objective. If you are looking at the PMBOK, then risk management is, it asks us to continuously evaluate exposure to risk, both opportunities and threats, to maximize positive impacts and minimize the negative impacts. Okay, so risks can be individual, or it can be overall. It has to be scaled to depending on the type of the project, so on and so forth. TCM talks about risk management in each and every step of the project management process and asks us to analyze the contingency reserves based on that. An important thing that we often confuse is enterprise risk management and project risk management. This slide here tries to explain it. We are working in an environment, so the enterprise risk management, the strategies or the risks of the enterprise flow down to the portfolio program and finally to the project level, while the risks from the project roll up to the enterprise level. So this is the environment that in which project risk management works. If you are looking at the project risk management, what is the exact process? You start the project risk management process with plan risk management, where you basically, based on your enterprise or risk appetite, you set benchmarks. Am I looking for an internal rate of return of 20%, or am I looking at an internal rate of return of, say, 11%, because I now need to break into this particular sector? The second step is identify the risks. So this is the traditional risk management that I'm explaining. Okay, So the second step is identify the risks based on various methods. You review the various documents, so on and so forth. You then come up with the probability assign, probability and impact, and come up with a qualitative risk analysis. Sometimes, depending on the size of the project, you go for the quantitative risk analysis where you run the Monte Carlo analysis. Or if the size of the project is small, then you can even directly go to the plan risk response process. You can, after quantitative risk analysis, you again go to the plan risk response. Once you have, where you basically identify the remedial or mitigating measures. So if there's going to be a monsoon, then what are the mitigating measures that I'm going to take to, do the adverse, remove the adverse impact of the monsoon period. You, based on the remedial measures that you have identified, you implement the actual risk response. This is concerns the actual project execution. And finally, you monitor risk. So you do a multiple risk review meetings based on quarterly basis, monthly basis, depending on the size of the project, and go on and go forth. So this cycle goes, repeats again and again. Now I am going, this particular entire process leads to various artifacts. So you have the PI matrix, you have the risk register as an output of this entire process. You have the probability distribution curve, cumulative probability distribution curve, which gives us the P80, P90 numbers. And you can have the Toronto charts of the activities affected or the risk. So these are the key artifacts that are generated by this particular process. So project risk management, I am running out of time. Anyways, I'll try to speed up. So if you're looking at the identify risk stage, the first stage of risk management, there are a number of inputs, basically the risk management plan, the tender document, so on and so forth, the agreements. You have various tools to identify the risks. So you have data gathering, you have brainstorming, number of meetings, and the output is the risk register. There are number of issues pertaining to this process. Basically, this is a manual process. It's highly time consuming and it is totally subjective and biased. Which brings us to the solution, the AI and ML part of it. Any problem and we turn to, earlier we used to turn to Google, now ChatGPT. But that is not what is artificial intelligence. There's a lot more to it. So there's self-driving cars, there are fraud detection, so on and so forth. But all the AI ML processes or algorithms are classified into different parts. So you have supervised learning algorithms, unsupervised, and reinforcement learning. So let's say image classification is a supervised learning problem, whereas targeted marketing that you often encounter on Google is a clustering or unsupervised learning algorithm. The AI/ML workflow basically starts with the defining the process, identifying the data source, okay, choosing the technology, what kind of models that we are going to use, training the AI model, testing and improving the model, implementing the model, and checking the results. One part that is missing is that there's something called as a model drift. So it goes on and the cycle repeats, and you have to keep on checking the results and retrain the model. The entire AI/ML process is implemented through various AI/ML algorithms. So you might have heard of things like linear regression, k-means, support vector machines. These are implemented through various frameworks, basically in Pandas, PyTorch, NumPy, OpenAI, TensorFlow, so on and so forth. Now, what we are talking about, due to paucity of time, I'll take up only 2 examples. What we are suggesting is that under identify risks stage, how do you implement AI/ML? What are your inputs? The inputs are your project risk management plan, your scope, your agreements, your procurement documentation, various procedures, project specific. What are all these? These are all in text format. Since it is text, it can be analyzed, especially using large language models or some kind of a classification models. So you have a AI/ML model that checks all these documents for risks, Now, each AIML result has something called as confidence level. So it can have a very high confidence or it can have a low confidence. If it is a low confidence, we have a human in the middle approach. Or if it has a very high confidence, if you have been running this model for a long time, then it can directly identify the risk. So what entire process, which used to take probably multiple meetings, 4-5 meetings involving maybe 50 odd people, and would run over a month or two, can be done in just at a click of a button. This entire process can be done within 1 minute, and it can be done multiple times. The second point that I would suggest, or where AIML algorithms can be implemented, is in the quantitative risk analysis stage. So what typically in quantitative risk analysis, you have a risk register, you have a schedule, you map the risks to the schedule, and you assign some kind of a probability distribution curve. Typically, you will select the normal distribution or the beta distribution. Now, this is actually wrong. What we are suggesting is that you deploy a AIML algorithm which is trained based on the risk, based on the activity. You link the schedule based on the type of project, where you are doing the project, who is your client, who are your vendors, what is the type of activity. It will help you select the range of risks or the average durations. Then you run the Monte Carlo analysis, which will give you the P90 or P80 values, which will be far, far more accurate than anybody else. I'll take a minute. Is it okay?
Abhishek, you are
Yeah.
running out of time. Just 1 minute,
fine.
please.
So fine, just 1 second. So, okay. So there was a slide on sentiment analysis. Sorry, I couldn't cover that. Basically, you are something like Twitter does a sentiment analysis. Similarly, we can analyze all your mails for risk sentiment and then merge it into your risk management process. So that is also possible. And finally, the entire process, can be different AIML algorithms can be deployed on the entire risk management process to automate it, do it much faster, much more efficiently, so that those ladies there need not carry firewood, and somebody has got better access to education. Thank you very much. Apologies for overshooting the time.
Thank you, Abhishek. So now I'll call upon Partha Pratim. He's a Chief Manager, Production Eastern Oil India Limited. Mr. Partha, please. Partha, you have 14 minutes to complete your presentation.
Good evening, everyone. At the beginning, I would like to thank my company, Oil India, and the Indian Energy Week for giving us this opportunity to present this story about digitalization approach, the starting of the digitalization journey in Oil India Limited. It's basically an approach to change the sand management strategy in Oil India Limited with the help of digitalized approach. So, in this presentation today, I would like to cover at the beginning the sand management and digitalization issues, followed by challenges we are facing because of the sand ingestion problem, then the objective of this pilot study, followed by project workflow that we have adopted during the process. And we'll go through a couple of pilot studies, and finally we'll discuss the value addition from this pilot project, and we'll like to conclude with our takeaways. So what basically sand ingestion is, as you know, with the increase in water cut and decrease in reservoir pressure, our wells started to produce sand. And sometimes it becomes so severe that we have to go for, shutting of the wells, and we have to go for walkover activities, right? So there is a huge, loss in terms of costs if you started to produce sand in your wells. And we have got a couple of active sand control methods, downhole like gravel placement, then your sand screen placement, and at the surface level we used to go for sand management, shock management, then your frequent cleanup of your vessels, separators. Sometimes we have to clean the tanks. So, and there are also lots of risks associated with your sand management, and there are some sort of metal loss happening because of the sand. So there are lots of problems actually we are facing, and we are trying to they create a holistic sand management approach with this digitalized tool so that we can, cover all the downhole methods and the surface sand control methods. So here in this digitalized solution, we have got 4 pillars. Number 1, your sand risk simulation, then sand production simulation, integrated solution, and finally the operating envelope. So creation of this operating envelope will help us to produce the wells with an optimum sand production throughout the life of the reservoir and the life of the well. The basic challenges, as I have already mentioned, we are facing lots of sand trapment at the surface, and because of the sand damage, the damage created by the sand, the downhole completion tools, we have to go for walkover for recompletions of the wells, and sometimes we have to go for some sort of complete change of the gas lift tools, gas compression strings. And we never knew about the quantity of the sand producing from each of the wells, right? And there are lots of the variation in terms of well profile, water cut, and that's why the challenges are more. And we are having lots of horizontal wells, then your intermittent gas lift well, PBGL wells. So with the variation of your complexity of well, your sand production, challenges will be high. So, and if in terms of handling capacity, if you are having some sand bridges across your purpose, there will be lots of positive spin creating finally the loss in productivity of the wells. So the basic objective of this project was, firstly, we were trying to analyze the facility integrity because we are facing lots of sand ingestion problem. Then we are trying to reduce the default production because of the sand ingestion issues and trying to avoid the walkovers. Then assessing the current status of your sand production strategies and the gaps we are currently having. And finally, of course, the reduction of the carbon footprint. So if we are having less engagement of your manpower at in the field level, there will be less carbon footprint. So regarding project workflow, the whole thing was started with your data collection, and data are in terms of reservoir data and hardcore your production data like well intervention data, then your sand sieve analysis data. So whole sort of data we have gathered for this project. Then we have used 3 software models here. One is SandMaster for facility modeling, then SandMaster for well level modeling, and followed by RockMaster, which is basically a rock mechanics model, which was used for developing the wells rock models. Post that we have analyzed each and every well in real time, real data has been analyzed, and finally we have fixed the algorithm for final prediction of the well's behavior. Then the recommendation phase, we have specifically categorized the well-specific recommendation, which have been implemented during the project implementation phase. And finally, full phase sand management dashboard will be created for the entire field, covering all the sand producing wells. So what basically the SandMaster is? SandMaster is a dynamic software model which can predict your sand ingestion from the wells with more than 95% accuracy. And this SandMaster can predict the one unique logic. Here I have mentioned like the unique logic for reciprocating sand, replicating the sand travel and the deposition behavior in the IGL well. It's a very interesting thing because the sand, knowing the sand behavior in intermittent gas lift is a very complex thing, and this SandMaster is helping out to solve that understanding in our intermittent gas lift wells. Then the RockMaster is a rock mechanics model. This RockMaster is being used to develop the MEA, this mechanistic art models, and the CDP profile, the critical drawdown profile. So this CDP profile and your ESPI, effective sand mass production index, are being used to optimize the shock sizes so that we can have a optimum production for the well for the entire the life cycle of the particular well. So it's a very useful tool we are using. Now let us discuss a couple of case studies. We have selected 3 wells for this particular study, and out of these 3 wells, 2 are sulfur, one is intermittent gas lift well. with the three basic objectives. One is to determine the critical flow rate of each and every well, right? Then the second one is the calculation of a sand deposition rate, and followed by the complete understanding of the sand behavior inside the wellbore of an intermittent gas lift well. So in the first well, we were having a production of 542 barrel of oil per day. When we analyzed the whole thing with the help of these two softwares, we calculated the optimum rate for this well is around 800 BOPD, at which rate you can have no deposition at all inside your tubular, right? So with this particular rate, you can flow back the entire sand particles that are coming from the reservoir, and you can lift up to the surface, right? The maximum particle size was 600 micron. Okay. So in this way, you can have optimum soak sizes at the surface, and at the same time, you have gain in terms of production, right? So and gain in terms of production, you are having some revenue for the company. So this is basically one of the biggest your benefit for us having this Rockmaster software, the Sandmaster software. And this is a very interesting thing actually. If you talk about the intermittent gas lift well, it's a very complex behavior we are facing in terms of flow behavior inside your tubing. And if you are having sand in a particular intermittent gas lift well, that the whole scenario of the production becomes very challenging, right? So you have to produce the slug from the tubing to the surface. At the same time, you have to restrict the sand production from the reservoir. So as you can see in this picture, the heavier particles, right? The A, B, C, these are the heavier particles, sand particles. These are getting deposited downhole, and the particles which are reaching the point of injection, like here it is around 2,300 meter. Those particles are getting lifted by the injected fluid, injected gas to the surface. So this is a very unique logic developed for intermittent gas lift well. And with regards to this particular unique logic, when we optimize the well, I mean basically optimize the cycle time of the well, it will be very beneficial for the well and in terms of production sustainability and in terms of production gain. So it's a very unique thing developed in our case for the intermittent gas lift wells. And of course, this had been validated by some of the well intervention trips. Yeah. So potential value creation from this pilot study, we can find out the time required for each and every well to sum up, the completely fill up by the sand. So basically, the time for some fill up was determined. Then we can optimize the soak sizes, and having the best soak sizes, you can produce the wells with the optimum rate, and we can reduce workover. And of course, you can have some sort of well revival plan, and which have been shut because of the sand ingestion problems. Then having a common dashboard for all will help you to visualize the data across the company, and knowledge sharing will be better. And reduce deferment. So in some of the wells, we are having GB completed, right? By proper understanding of the well behavior, we can just omit those gable pack completions and have some good production. Okay. In terms of cell flow well, we are calculating the critical flow rate cup, which are helping to get the optimum production from these wells, sand producing wells. And of course, that your operating and development of this operating envelope is a very good thing for us, and it will help you to produce the critical cell flow well as well as the intermittent gas lift well in a sustained way for a long time, for the entire life of the well. And lastly, the less carbon footprint because of the less manpower engagement in the field, right? So if you have digitalized solution, then you can reduce the manpower at the field, and you can have some sort of digitalized solutions, and ultimately less manpower engagement will give you the less carbon footprint at your installation. So in terms of potential achievements we are having from this project, number one, from this project we can understand the sand behavior very well from your near wellbore to the surface facilities. And this surface sand management using this digitalized tool is helping us a lot because of this sand management, surface sand management strategy. We are being able to design the hydrocyclone and proper sock selection at the surface. And last but not the least, the incremental oil gain. If you talk about the production from a well, sand production has always been excellence, and this digitalized tool is being helping us a lot to fix the shock sizes of the cell flow well, and at the same time optimize the cycle time of the intermittent gas lift well, leading to the production gain. Ultimately, it will give us revenue for the company. Thanks a lot. Thank you.
Thank you. Thank you, Partha, for completing in time and a wonderful session. We have two more speakers, and now I will call upon Mr. Tarun Kumar Mishra, Founder and Chief Strategy Officer, Detect Technologies. He'll be speaking on owner's intelligent toolkit for smart project monitoring. Mr. Tarun, please. You have 14 minutes to complete your presentation. Thank you.
Very good afternoon to everyone here. I am Tarun Mishra. I am the founder and director at Detect Technologies, one of the leading companies in the area of in the area of AI and SaaS. We are one of the leading companies globally, and today we will talk about the work that is we are doing in the area of project management, specifically the capital projects that is there. Our Honorable Prime Minister said already about the amount of investments going into the energy infrastructure, and we all are aware about how it is increasing. Globally, if we see today, about $1 trillion is being invested into capital infrastructure in the energy sector, and it is supposed to increase to about $4 trillion by 2030. However, around 2.5% only of these capital projects are able to achieve their successful execution in terms of scope, cost, business, and other aspects of a capital project. Now, we are going towards process excellence, operational excellence, but today more than 50 plus AI applications have already been identified and being deployed in capital projects, which can be used to enhance the efficiency by more than 20 to 30% overall. So, talking about some of the known applications, see, AI is a buzzword. So, we should understand this very clearly, what is aspirational and what is practical. When we talk about certain things which are trending, such as blockchain, cyber security, and few of the things which are related to AR and these aspirations that we are building, these are things which are of emerging trends. They are evolving. But today, unfortunately, there are no practical applications where there have been a clear established returns that have seen through these applications of AI. There are obviously the research areas which are emerging, such as your AI-based contract management, AI-based applications in certain areas of document management, and so on and so forth, where research is going on. But again, there hasn't been something that has been truly established in these areas. When we understand some of the opportunities that are actually existing today, where AI is clearly making all the difference in the world, we see some of the applications such as your integration with building information management systems, the health and safety analytics. There are things in terms of estimation, stocking, and so on and so forth, where there is a clear opportunity, and there the world is clearly taking advantages of such opportunity. Today, I want to talk about these opportunities in a specific focus. So, let's talk about the most mature application areas where it comes to construction and project management specifically. So, I have divided it into 4 key points. One is safety. Safety today, when we talk about OSHA, when we talk about IOGP or Canadian or European standards, there are all these different type of safety categories today which can be automatically detected and proactively acted upon. I will dive deeper into this. Then there is obviously the security aspects, whether it is face recognition, number plates, intruder detection, theft detections, that can be today automated, or the inspections, which is related to your compliance checks or design versus actual considerations, the asset inspections on site, how the reliability of those assets are, as well as site performance monitoring, which is your schedule to actual making sure that we are able to forecast and achieve the catch-up plans, the issues that are there, their visibility of it, as well as the performance monitoring. All of these today are possible using AI. Just a quick trivia. As per NIOSH, construction accidents can be reduced by close to about 20% using AI-driven safety systems. This is a big number which can be seen very clearly through some of the statistics from what we have experienced in different sites. 78% of risks are clearly attributed to just 5 categories. But then again, 13% of actual accidents that happen on site, nobody is able to find out the root cause of where it came from. This is a graph which tells you some of those very trivial things which we generally do not pay attention to causing the fatalities at site. If we are able to make use of all the existing infrastructure on site, such as your cameras and other visual devices, and bring intelligence into that, we can clearly create a gold standard of safety across all the construction industry that is out there, and make sure every single project comes to a safe execution in a fully automated manner. How these can be done? We should be able to leverage our existing infrastructure, the existing cameras, the existing sensors, the existing devices such as handheld devices or helmet cameras. Any kind of a visual devices can make the data flow into a central AI engine. This central AI engine is able to do a lot of things, including making sure that the relevant incidents or observations are identified and reported on a near real-time basis to the managers, where they can proactively avoid any accidents. Let's take an example of a case study. In this particular site where we have deployed the solution, 90% improvement in leading indicators was identified. Near about 29 near misses were avoided, which could have resulted in fatality. And despite of 7,500 plus observations, which is that of non-compliances, there were 0 accidents on site, which tells you what is the level of proactive nature that we can bring to site to ensure a safe execution. These are some other examples where, due to proactive identification of hazards such as unsecured loads that are present on sites, and correcting those such kind of near misses, we have been able to identify fatalities. Due to paucity of time, I will move forward into the next sector, which is security. Again, a data trivia, which is from IDC. We can reduce false alarms by close to about 90% in security related audits and findings by using the correct AI and the most accurate AI. Here, in any construction project, if we see the data very closely, about 56% of the total project face theft. There are 60% of the project where there are different types of data being generated from different security teams or the audit measures, where there is a silo that is created on data, and 80% of the construction projects today across the world face the problem of intrusion. AI can help you in solving all of this at scale. We can have intrusions detected automatically in real time. We can have suspicious activity as well as your suspicious equipment movement or theft or man movement in odd hours, exposed pipelines, exposed nature of tapping or unauthorized inventory movement itself can be detected, and we can identify in real time what exactly is happening to the capital goods and spares and whether they are secured or not secured. This brings a world of change when it comes to the capital project management as well as its security and sustainability. This is a practical case for that. In one of the clients, what we have seen is just in a matter of 2 quarters, what was supposed to be 300 to 400 such kind of theft and pilferages has come down drastically by about 70% by using AI at their site. This makes more than $1 billion of savings in such kind of customers. There are benefits on financial level, business level, technological level, which leads to more than 80% improvement in most of these areas when it comes to security overall. Again, on the third aspect, which is that of inspections or on asset management, Here again, I will start with a trivia of a data. We can reduce construction rework by up to 30% and decrease project cost by 10% if we are able to bring in the correct amount of interventions using the AI and processing of the data that is available. Progress inspections, whether it is through analyzing the design specifications actually on site or not, whether there is the civil work or structural work and other kinds of activities related to project execution happening in the right manner as per the plan or not. These things today can be measured in a very automated manner using AI. Similar thing is for equipment and off-site monitoring, resolving any type of remaining task or finding out the issues that are there on site, resolving those issues in a sustainable and a scalable manner, and bringing those updates in real time and bringing the clarity in how to solve those execution related issues can today be centralized and can also be automated so that the same resolution is applied from there on out. So this is the last aspect, which is that of AI enabled site monitoring and performance evaluation. Here again, if we see the site delays, as I talked about, only 2.5% of the overall projects see the light of the day where they are actually successful. So we can reduce project delays by up to 20% and improve overall project timelines. How we can do it? We can engage with the last mile to the top plan. We have the most of the problem lies in data collection. If we are able to ensure that is the correct way of collecting data, democratize and large plan into smaller pieces, empower the last mile people and tell them what changes are being done at the top in a seamless manner and connect it to the bottom. So we can bring efficient problem resolution, we can bring cost and time savings, we can also bring streamlined documentation as well as enhanced project visibility. A group of experts sitting somewhere in Hawaii can connect to a person sitting somewhere down south in India and make sure they are able to pass on their instructions in a very clear and comprehensive manner by using the part of streaming live from their handheld devices and annotating and giving the instruction in real time. These all things today are ensuring that we are connecting last mile to the top plan and thereby bringing visibility into all forms of execution. In summary, if we bring in AI in aspects which are related to execution, planning, security and safety, there is a clear established benefit now that has been realized by many industries and many construction projects. So that is what I wanted to share today with everyone, and happy to take up the question post this session. Thank you.
Thank you, Tarun. Now we have one more speaker. Now, Mr. Vivek Jaiswal is Executive Vice President, Renew Energy. Please welcome Mr. Vivek Jaiswal. He'll be speaking on the leveraging Industry 4.0 for EPC management in renewable energy projects. Mr. Vivek, please.
Good afternoon, everyone. And being the last speaker of the session is a tough job. And to hold the audience even tougher. And let me try, and thank you for taking time for this session. You know, more than 3 decades into construction projects and last more than a decade and a half into renewable energy, I've come to realize you have only 2 kinds of projects, the good projects and the dead projects. And once you go a little deeper, and I had Chairman GE visiting me, and I was that time with GE, and I was briefing him on some of the projects that we were doing and the challenges that we were being faced. Then something it struck me, and I asked him a question. I said, Larry, would you drive a car that doesn't have a dashboard? He looked at me very quizzed. I mean, what kind of a stupid question is this? I said, it is what it is. And today we have $1 million, billion-dollar projects that we do. And these projects really don't have a centralized control structure. That is under the system that we operate in. So there are only 2 things that we manage in a project and nothing else. There is a risk on a project, and you said it well, and there are opportunities on a project that we handle and we exploit all the time. Just look at the size of the opportunity. Renewable energy is a $6.5 billion opportunity in India, 2024. So if this is the size of the opportunity that we are sitting, is there a case that we can get Industry 4.0 technologies and get them into the EPC industry? And if you please take your minds back, EPC industry is one of the oldest industries in the world. It's more than 3,000 years old. So go back to the time of Harappa and Mohenjo-daro and you'll still find an EPC industry there. That is the beauty and the time span that this industry has come in. How do we solve this puzzle? And I think a couple of speakers before me have already said about cost overruns. I've been very conservative in my numbers. There have been bigger numbers that were shown on the screen. So I've just said it's 10 to 15% cost overruns, scheduled rather than 3 to 9 months. Why have I done this? Basically, I'm looking at it from renewable energy projects perspective. Other projects, this will be higher, for sure. And the short duration, because renewable energy projects are 9 to 24 months, and we work in a very intense environment, partly controlled, partly uncontrolled, somewhere semi-controlled, highly regulated, even regulatory, the regulatory policies are still getting evolved. So we are in a very tough space when we do, and the pace at which India wants to commit to renewable energy is 50 gigawatts annually. And what are we really reaching today? Not even touching 25 to 30 gigawatts. So you have to see the backdrop in that we are trying to do all of this work. Let's take another 2x2 matrix. It gives us a very good view. So you see, when you come and make a nuclear plant, it is a concentrated construction. There is deep planning which has gone in. It takes 7 to 10 years to get the plant activated. Look at a hydro plant. There are many years of seismic studies, hydrological studies that are done before a hydro plant comes in, right? Now, after that also you look at the projects which have just been done and they've been delayed. You look at the Teesta Hydel project. You got so many of these examples. So 7 to 10 years is the time that it takes. And you have all the time in the world to plan. Then you have thermal projects. Come down to renewable energy projects. How much time do I get? I barely get 9 months to 24 months to churn out a project from 20 megawatts to up to about 600 megawatts. That's the only time we get to do work. It's like playing a T20 or a T50 match. It's not test cricket anymore. And that's exactly the problem we are trying to solve. So why not then change the whole, there's a paradigm shift here, why not change it? Then look at it differently. If this is the mechanism or the circumstance under which I'm going to play a T50 or T20 match, then okay, let it be. Then let me look at the industry outside and go for lateral technologies. And that's where Industry 4.0 fits in exceedingly well to solve this problem. This is the landscape. Now I've tried to take a marriage, what can come between Industry 4.0 and renewable energy EPC 4.0. And also keep on the side that there is a infrastructure built up on the 5G network, which has to support this. So it is not in isolation. You cannot do one thing in isolation. And even the speaker prior had made the same mention, and I fully agree with it. The question is, there is a maturity of every technology that comes in, and that maturity has to be seen. So if you just look at the technologies I have listed here, some of them are in an extremely advanced stage and being used in the industry. So you've got drones being used, cloud computing being done, there is cybersecurity, things of that. There is at the fringe level, you'll see IoTs coming in. Why is IoTs not taking off right now? It will take off. It is just waiting for 5G highway to open. And 5G highway is around the corner. It's just going to open. Moment 5G opens, IoTs will open. AI, ML, IoTs, they all go hand in glove. They're all together. You have some part of the remote robotic process automation, documentation is one piece of that work. You can do that. There are smaller parts of the puzzle which are still not solved. So there are 3D technologies And we've looked at it. We even tried to do a 3D printing of a wind tower. Wind turbine tower, just imagine it has been 3D printed. And this is already a test case running in this case. Then you have blockchain. I'm talking of permission blockchain. I'm not talking of non-permission blockchains. So no crypto here, right? So that's the kind of space that we are working in. Let's also say then what is the fix? If this is the space, then how do we put it together? Very simple. Go back to 3,000-year-old structure. You have only three things to solve for. There is an engineering phase, there is a procurement phase, and there is a construction phase. Now, rather than going and making one standard solution which will never fit anybody, and then wasting your time over it, and then breaking your head and saying it doesn't work, change it. Part of that work I'm doing with Vaibhav, so he knows on the other side of the work that we are doing. The interesting part here is that let's not boil the ocean. Let's solve what we can solve for. There are within the company, you will find there are enough functions that are digitally quite mature. Not every function is growing at the same level of digital maturity. So somebody will have SAP working, somebody will have some other system, somebody will say I've got Gen Suite working. So different people will have different things working. Don't worry, that's fine. Then all you need to do is set up something that can connect systems. So make a super system that connects systems. That is the way to go. If you now go and make one size fits all, we fail again. I've been through this journey umpteen number of times and no more. Then, finally, all this looks very nice to say it. It's very easy to even articulate your position. Where do you get stuck? So while I was deeply thinking, I said, what would be the final 2-3 things that trouble us most? When we say, okay, this seems very good, you're talking the right things, you're doing the right movement, you will see improvement, then why do things not move? I think the most important part, first and foremost, is the approach that we take to solving a problem. Usually we are trying to solve a problem with a software which will solve everybody's problem. There is no software which will solve anybody's problem. So you'll have to narrow down and say, what part of the problem am I trying to solve? Just stick to it. And there's a large scale landscape available to you. First thing. Second is, let's not also go and ask people, everybody has something that's working for him. Build on what is working. Let's not change what is not working. So best case is, what is working, just connect it the way it works. You will always be challenged and pushed back on data privacy, but I think there are enough tools today to solve that part. That's not too difficult to solve. I've learned another lesson in my life. I call it this way. A bad process automated is made disaster faster. Usually what happens is, you find most of the time who does the domain work. And please, my IT friends here, don't take it amiss. It's not a pointer toward any one function. The people in the domain are the domain specialists. They have to lead the show. You cannot have IT leading the show. It doesn't work. A domain specialist will have to take the leadership position and he has to lead. Once he leads it, before jumping in and trying to digitize the process, please go review the process first. That process may be so archaic that you digitize it and it will be accident all the way. So better that process first needs to be dumped. Get out of the process, recreate a process, go to IMS, put the process up there, test the process first, and then bring it down into automation, not the other way around. And I think the one that I think that I've been partly able to crack the puzzle, and that's why I looked at Vaibhav. The way we are trying to crack the puzzle, this is the toughest one. The toughest bridge to cross is the cultural bridge. Every other bridge you can pass. This bridge, it's a nightmare to cross because every one of us are victims of habit. So nobody wants to change. So why do you want to change? The question is, you don't have to change. So how do you sell change? I'm not batting today for Colgate toothpaste, but you show Colgate toothpaste 20 times a day, and 21st time you ask, how do you brush your teeth? You say Colgate toothpaste. So how do you do that when you build a process, any structure like this? You sell it along the way. Don't build it and then try selling it. If you build it and try selling it, it will never sell. And you will be sitting where you are at zero. So along the build, test everything that you wanted to test. So all my frameworks that we build, we test it. How do I test it? Well, a little secret, I let it on with you. I test it through my PowerPoint presentations. So I test my product along the build. So I see what is selling, and what I do, I just seamlessly interchange. You will not even come to know when I've changed. I've just removed the presentation, I've just put the UI changed. So everything is on the server now, but you can't make out the difference. It's just the same. So you test and build the process just as you go on. And that is the only way that you will get past the culture. Otherwise, we are going to be in trouble, for sure. Then there is a problem that I think somewhere we've been able to crack this one also, is to say everybody thinks data is power. Yes, data was power. Data is not power anymore. ChatGPT has proved it to every one of us. I mean, if you try and sit on data, you are the biggest idiot, I think, that we can find. What you can really do is you can give that power back to the function. Give him, don't disempower him. You further empower him by taking data, you give him analysis back. Don't push him out of the total value chain. Please never push him out. He exists there for a reason. You just enhance his value. Today's value is X. Make it 2X. And you will find that you would have crossed that hurdle as well. So I think that's what I've tried to write here. If you put the cultural thing, the last part of it, is you create a platform mock-up that you run it along the way, and while you're trying to do it, solve for adoption. If you don't solve for adoption, you may have built the best product in the world, but it's not going to run. It is just a Taj Mahal which nobody will ever visit. I've finished. If there are any questions, I thought I've got a minute for questions. If there are any questions, happy to take them up. Thank you.
Thank you, Vivek. With this, we have come to the end of this very absorbing session. I would like to thank all the speakers for their very thought-provoking presentations and the lovely audience with their patient hearing. Thank you very much. But I think Vaibhav, you'll like to close it.
Yeah, I think it was a great session. A lot of good insights on how we can leverage technology for our projects. So I'm sure there are good takeaways from here, and let's work on implementing them. Thank you all.